The next problem statement is the iris flower statement. It is very popular and it has three species: Setosa, versicolor, virginica, which differs according to their measurements. As we all know that it it has various features like sepal length, sepal width, petal width, and it mentions about the species. We'll talk about this in a while. The IRIS dataset is a classic dataset in the world of machine learning. It contains the measurements of three species of iris flowers: Setosa, versicolor, and virginica. So here the sepal length is in centimeters float, the sepal width is in centimeters float, petal length in centimeter float, petal width in centimeter float, and the species. So let's get started. We have 50 instances of each, so quite a small data set, to be honest. Imported the libraries as usual, the pandas for data analysis, numpys for data analysis, matplotlib for data visualization, seaborn for data visualization. Warnings if seaborn generates any. We load the dataset, we check the first five values, and you can see we'll see the mean out of it first using the describe. The 5.83 is the mean of all of them. 3.05 for sepal width, 3.75 for petal length, and 1.19 for petal width. Next, we'll create pair plot. Yes. We'll create a pair plot to analyze. We are using the species as the U. We can see that the data is getting accumulated and categorized by its own. So see, here the setters of lava, here is the versicolor, here's the virginica. In real life, the data is not so categorically different, but here it's since it's just 50 instances, we can see that it's getting divided into categories. If we observe properly, the petals are getting divided into categories uh, more properly than the sepal ones. So we can use the petals for our training rather than the sepal length and width, and we'll see that in a while. Next, we create a correlation matrix using heat map, and over here uh, we can see that petal length and the petal widths are obviously related. Next, we have the petal length and sepal length a bit related. The sepal width and petal length are not at all related, so we can ignore these. Yeah, we can work on these. We can use the this consideration in our further analysis. Okay, so the next is we're creating a KDE plot. So the purpose for using a KDE plot uh, is to see the distribution of sepal length and sepal width specifically for the Setosa species, which provides an insight into the characteristics of this particular iris species. You can see sepal length and sepal width and how it is getting divided into various categories. Yeah, let's go ahead. Now is the time for the training and testing. We import from the scikit-learn, we import the train test split function. For the X, we are using the everything except the species and species column. And for the Y prediction, we are using for the Y, whatever we have to predict, we are taking it in Y data set, so we need the species. Now we are splitting it into training and testing data set. We are using 30% of it for testing. Next, we are going to use SVC. From the scikit-learn, SVC is support vector classification. Um, Now, the reason why I'm using a support vector machine depends on various factors. It helps in handling non-linear data. Uh, it uses the kernel trick that allows it to transform the input space into higher dimensional space. Next, it is robust to overfitting and it is effective in high dimensional spaces. The iris dataset is relatively small with only four features like sepal length, sepal width, as we had seen over here. Sepal length, sepal width, petal length, and petal width. Um, SVMs can handle high dimensional data efficiently. Now, yes, so we build the model and then we use it for predictions. We predict it. Then after prediction, we need to check the efficiency. So the this c- this the purpose of this using this is that it creates an evaluation matrix from scikit-learn, including the confusion matrix and the classification report and the accuracy score over here. And this is if then it then prints these metrics to evaluate the performance of the trained SVM model on the test set, providing insights into how well the model is classifying iris flowers into their respective species. You can see we are getting an high accuracy of 95%. Since this data only contains 50%, 50 instances only, it's rather small. So we have such a high accuracy. In conclusion, I would say that I enjoy doing this project. It was quite easy because I had already tried this during my learning process of training the iris data set. So yeah, this is the task one, and thank you so much for watching.